Swayam Prabha. Digital India. Educated India.
Let us start this lecture with a thought process. Self-discipline and self-knowledge are two essential wings by which you can achieve excellence in life. If you recall, in the last lecture, basically we derived a relationship for fixed law, and later on we made it a very what you call generic relationship for relating all three constitutive laws: Newton's law of viscosity and Fourier's laws of heat conduction and Fick's law of mass diffusivity, right. And then we try to invoke the theory, molecular theory of gases, to relate to the mass fluxes, right, so that we can find out express this so that we can express these properties in terms of molecular properties, right. And in the process I also emphasize that we need to look at the mean free path, and already we have a derived relationship for the average velocity of a molecule, or the molecular speed, average molecular speed. And let us now derive a relationship for a mean free path, right. You can say length or mean free path only. So, considering that this for an ideal gas we are considering, that is contains the molecule of same diameter d, right, and we know that these molecules will be moving at an average molecular speed v dash. Mean molecular path is basically what? It is the average distance, right. It is average distance traveled by the molecule, right. It is average distance traveled by a particle. I will be saying particles, right. And particle basically it can be atom, it can be molecule, it can be radical, before colliding with another particle. And keep in mind that this particle is d sigma is the diameter of a particle with average velocity, average molecular v dash. And right. So, what is this L then? L, if I look at this L collision, is nothing but your V average and delta t. What is the delta t? That means the time taken during the flight between the collision, two collisions, right, divided by this is number of colliding particles, right. Let us consider that there is a particle, right, which is moving at a velocity v, and this diameter is basically sigma, right. And keep in mind that we are considering this particle is moving and it will be colliding with other stationary particles, right. Let us to make it simplified, right. Now, I can say that this will be, let us say, moving in a volume. There is another maybe fixed particles which is away, there might be fixed particles here, these are all fixed particles, right. This is fixed particle, this is of course moving with that. Now, this diameter, if you look at this one, right, what will be this? This will be 2d, because this diameter distance, if you look at, it will be 2 sigma, right, because this and there is another this thing, right, 2 sigma. If you look at the volume, you know, it is swept by this, the swept volume, what it would be? It will be this cross sectional area 2 sigma, right, and into this velocity with which it will be coming. So, that is the thing. Now, keep in mind that let us say this is 1 and NC is number of collision. And delta T is basically flight duration between collisions, right. And in this volume, if you look at, there might be several molecules which will be coming and colliding, right. So, therefore, like we will be looking at the swept volume, right, during flight delta T would be basically pi by 4 2 sigma square into V average delta T, right. And number, if you look at number of collision per unit time, what it would be, because I am really find out NC. What will be NC? NC will be this swept volume, right. I can say this is basically swept volume into what it would be, into number density. N is the number density, right, where I can write down where that is number of particles divided by volume, right, that is your number density. So, that will be basically, if you look at, this is nothing but your pi sigma square V delta T, this is pi sigma square V delta T. And keep in mind that here we have assumed that one particle is just moving and rest of the things are stationary, but in real situation all the particles will be moving with, let us say, same velocity. Therefore, the relative, you know, what you call relative velocity, average velocity will be basically, that is, but all molecules, as I told, are moving and colliding with each other. then the velocity, relative velocity, I can say will be basically root over. Then NC, if I say this is NC, NC would be basically root over pi sigma square V dash delta T, right. Now, what I will do, I will then by using equation 1 and 3, we can have L collision will be V delta T root over 2 pi sigma square V delta T into N. N should be there here, into N, this will be N, okay, N. So, this will cancel it out, V will cancel it out, it is nothing but 1 by root 2 pi sigma square N. What it indicates? It indicates that the mean free path is basically proportional to the diameter of the particle or the molecule. If diameter is bigger, the mean free path will be smaller, and if number density is higher, the mean free path will be smaller. Is it inversely proportional, right? Because if it is the more number of particles for the same volume are there, that means it will be going and colliding is very easily. Keep in mind that in actual situation the mean molecular path will be zigzag, but in this thing we have considered as if it is going in a particular volume, you know, that may not be really the case in actual situation, but here for simplicity we will consider. Now, let us take an example, right. Determine L collision of air molecule of air at STP, standard temperature and pressure, and which is moving with velocity v 485 meter per second, right, and we will have to determine that. And as I told, the pressure is the standard pressure, so we will have to basically find out the N, and the diameter, if you look at sigma, is given as 2 into 10 power to minus 10 meter. This is the diameter of air molecules, right. Of course, it might be, you know, oxygen and nitrogen, but we are considering as a single one, right. Okay. So, if that is the case, then what will happen? We know that L collision is equal to 1 over root 2 pi sigma square N. So, N we will have to find out. N is basically equal to N naught by V, which is nothing but your P by Kb T, right. Kb is your Boltzmann constant, right. So, P we know 101,325 and Kb is 1.38 10 power to minus 23 into standard temperature. So, we are taking 298. So, this is coming to be 2.5 10 power to the 25 meter minus, like 1 over meter cube, right, unit 1 over meter cube basically, because this unit is there, is a number on a volume. So, now if I substitute these values, L collision will be 1 over root 2 into pi 3.14 into 2 into 10 power to 10 whole square into 2.5 10 power to 25. So, that is happening something 2.9 into 10 power to minus 7 meter, which is happen to be 1500 diameter, right. So, if you look at the mean free path, it is is equal to order of something generally something for gases around 1000 sigma. Here it is 15, order of 1000, not that exactly 1000. And the distance between these two molecules will be order of something 10 sigma. That is where we use the ideal gas law. Now, we will be looking at basically how we can relate this thing with the properties. We will be now using the mean free path with the properties. So, let us consider that this a chamber or a cube in which the particles are moving with certain velocity v, average molecular speed, and we will assume that it is having some flux which is continuous in nature or some properties which is continuous nature, right. If I consider this, let us take a plane and this plane, let us take this as basically y direction, and I can take this is x and this is your z direction, and this distance we are considering because the collision will be taking place with the mean free path, average distance. We are considering this as a L collision, right, and similarly this also we are considering as a L collision. And in this plane, let us say these properties will be psi naught, and here we are considering psi plus and here considering psi minus. And this you keep in mind that this property, what are these properties? Properties can be mass, it can be energy, it can be what we call momentum, right. So, these properties are continuous in nature, keep in mind that this is very important. Are you getting? In the when you are considering molecules, these are discrete, okay. Here we are considering as a continuous, right. Now, what will be the net flux if I consider in this plane where it is 0, this is basically 0, right, 0 plane, and this is going L collision distance this side and L collision distance that side, right. It is very, very small, we have seen it is 10 power to minus 7 for air, it is a very, very small distance we are considering between two planes, just two. And what will be the net flux then? Net flux would be, right, and keep in mind that there is a total we are considering along, let us say y direction, but there might be what you call x direction and then z direction. So, therefore, there will be total basically 6 planes which will be coming. So, number of particles, if you look at average wise, it is the total is 6. So, therefore, it is moving with a velocity, the particle is moving with a average molecular speed, right, and that will be V, and these properties will be psi minus psi plus divided by 6, because this is a velocity with which it is moving, this is a basically you can call it as a flux, right. And if you look at like this psi, like I can use, because they for a continuous function, by considering psi as a continuous function, and using Taylor series, we can have psi minus will be psi minus d psi by dy into what? L collision, this distance, yes or no? This will be not, yes or no, right? Similarly, if I say this is equation 1, similarly I can write down psi plus will be psi naught minus d psi by dy into L collision, mean free path, right. Now, if I use, let us say this is equation 2, both the thing together, if I will use equation 2 in equation 1, and equation 1, we can get net flux. If I say net flux is nothing but your theta is, if I say this is V by 6 and psi naught is coming psi minus, okay, psi minus psi naught minus psi by dy L collision minus psi naught plus d psi by dy L collision. This will be plus, okay. So, therefore, this will be minus, because this is in the positive direction, therefore, this will plus, this will be negative, right. And what you will get basically, that means this will cancel it out, you will get L collision by 3 with a negative sign d psi by dy. Now, if you look at our constitutive or the compact form, what we derived is basically theta is equal to diffusivity minus d psi by dy, this is 1, right, this already we have derived, right, and this one is basically V minus L collision divided by 3 minus d psi by dy. Is it not looking similar, right? Only what we have done, the diffusivity is nothing but your average velocity into collision mean free path divided by 3, that is all, right. Are you getting this? Is simple, because I have derived this relationship or I have looked at this compact form, right, because of do this, right. And now we look at how we can relate this thing to the properties, various properties, of course, all right. Now, if you look at, we have derived this thing, theta is basically diffusivity d psi by dy, and if you look at tau yx is nothing but your mu rho vx by dy, right, and this is the thing we have derived, and which is nothing but your what you call minus v rho Vx, this is flux is basically nothing but your dy. So, therefore, I can write down mu is nothing but your V L collision divided by 3 into rho. Let us say I can say this as equation 3, can I say, or equation 4, 3, right, 3. And what we will do? We will now substitute the relations for the average velocity and the mean free path. So, because average velocity we have seen, that is 8 kb t by pi m root over, and L collision we have seen, what is that? 1 over root over 2 pi sigma square n. This already we have derived. So, what I will do? We will use this thing, right. Then equation 3 becomes mu is 1 by 3 8 kb by t pi m and 1 over root 2 pi sigma square n into density, right. So, this is your expression, you can look at it, right. And similarly, I can get the relationship for the q dash, right. We know that q dash is equal to minus k rho, I will say Cv d rho Cv t into dy is nothing but V average right. So, therefore, I can write down the K conductivity will be what? Nothing but your V L collision 3 rho Cv. Let us say this is 4 and this is 5. Of course, you can substitute these values of V and L collision here, I am not doing that, right. And let us now look at mass diffusivity equation A d by dy, which is nothing but V average L collision divided by 3 into. So, therefore, I can write down basically diffusivity as V L collision by 3 simply, okay. And if I substitute here V average here, what is that? 1 by 3 8 kb t by pi m root over into 1 over root 2 pi sigma n, right. And keep in mind that I can simplify little bit here. I can say this is basically 2 by 3. So, I will get basically kb, right, t divided by pi m and 1 over pi sigma n. So, what is this n? For ideal gas, right, n is nothing but your n naught by V, right, okay. And PV is nothing but your n naught kbt. So, I can write down n is nothing but your P by kbt. Okay. So, therefore, I can write down this as, this is your d. So, I can write down d as 2 by 3 root over kBT pi m pi sigma square p by kBT. So, therefore, I can write down as 2 by 3 kBq T by pi q m, this is half into T sigma square p. That means what is indicates? It indicates that d is proportional to T T what 3 by 2, and also it is proportional to, inversely proportional to pressure, right. But if you look at rho d is proportional to T half only, right, and in some cases people is assumed to be constant because not really very much changing. It is not true, but they can assume it to be constant diffusivity, right. So, now we have seen considering basically the molecules, right, without rigid spheres, and but actually the spheres need not to be rigid, right, and it is spherical, and the molecule need not to be spherical, and we have also assumed the elastic collision, but collision need not to be elastic. Okay. So, now we will be in the next lecture we will be discussing how we can incorporate those things little indirectly, but not in, I am not going to discuss at length about that, but little bit I will be touching upon how we can do that. So, with this I will stop over, and thank you very much.